Good morning, good afternoon, good evening, wherever you are in the world right now. Welcome back to the OPC Day International 2022. It's the day 3. So I was just thinking what Bergfest means, but right now I couldn't think about the quick English translation. So it's in the middle if you reached the peak of the hill. And this is exactly the third of 5 days. The first day, just to give you a short recap, was exactly all about keynote speeches, where we believe that one of the biggest challenges of us human beings here to save the planet is the energy transformation. And we had fantastic presentations. And even I'm a very communicative person. I was speechless listening to that project, how to capture the CO2 and store it somewhere. That's brilliant, and I believe we will hear much more on that on the future. On the second day, it was on technology. Definitely we learned about security, but also had a focus on the communication to the cloud, from the edge to the cloud, on MQTT and the mapping of OPC and the flexibility on different messages to be very flexible and meet all the requirements in the factory and the plant. And we had an update from Peter Lutz on the field level communication initiative. Before we start on the day 3, it's about the collaboration. I want to give you a short preview on day 4 because tomorrow we are again looking on more technology-oriented presentations. Jim Luz, the CTO of the OPC Foundation, will explain us about the challenges and the solutions when you deal with multiple OPC UA-enabled assets. So not just how can a client talk to a dedicated server, it's more on I have a factory, I have a huge plant, I have dozens, hundreds, thousands of devices. How can we discover, how can we establish security and all the certificate mechanisms and handlings on this. We will have an explanation from Erich Bahnstedt about how does systems fit together and the technologies fit together, how do they interact with OPC UA, with MQTT, with the asset administration shell. Sometimes we realize that people get confused. Where should I use what? Erich Bahnstedt is also the person behind the cloud library. Together with Jonathan Malessa from INRAE, they are not only explaining what is a cloud library, because this has been released last year already, but it is already industry standard. It has been realized in commercial products, and this is what both of them are explaining. Then we have back our keynote speaker, Espen Krogh from Predictor. He is giving us feedback and explaining real-world success stories on OPC UA in the world's largest offshore and solar panel projects. And we are happy to have a speaker from L'Oreal also talking about what OPC UA is an enabler to increase the operational performance in their plants. On the day 5, just to have a short summary, we are getting a couple of presentations, always focusing on one dedicated challenge and what OPC provides as a solution. We will have multiple speakers and I will introduce them on Friday morning. So back for today on day 3, we have multiple presentations where we are focusing on the collaborations. For example, we have in detail, after my presentation, something about the digital transformation in between the LADS and CAISI companion specification. This is challenging, I tell you, this is great and fantastic. It's a new announcement. We get multiple presentations from the VDMA here, because remember, they are our key partner on defining information models, but also on the harmonization of information models. This is exactly OPC UA for machinery. And we have another new announcement presented by Dr. Matthias Jöst about the XYZ coordinates, the global positioning and the cooperation, what we do with their omlox organization hosted by P&O and the OPC Foundation. And last but not least, Dr. Wolfgang Mahnke, he's the leader of the harmonization group, is giving us an update what is happening in the harmonization world, what is coming up in OPC DI, which is for the benefit for everybody. With this short introduction of the day today, I'm asking again everybody, feel free, put your questions into the Q&A window. We are answering them, trying to do them live in the background, and we have a Q&A session right after all the presentations, moderated by Alexander Almendinger. He's leading the lab in South Germany, Stuttgart, Göppingen. And let's start with presentation number 1. Yeah, and that's my presentation. Welcome back, Stefan Hoppe, the president of the OPC Foundation. I want to give you a short update on the overview, the process and the agreements, how we start collaborations, what is behind, what are some rules. It is just a very short introduction here. Remember that we gave already an introduction on these collaborations as the key for the digitalization. I truly believe that yes, we need somehow protocols to move data from A to B, putting it in a pipe on the one side and it comes out somewhere else. Might be a horizontal pipe, might be a vertical pipe from somewhere to somewhere. But one protocol, one pipe is not enough. It's not fulfilling the needs, what we have today in the industry, where we might have to combine multiple protocols because the data first go wireless, then into a cable. Sometimes we need deterministic transport, sometimes we need additional functionalities like functional safety. Sometimes we have a logical one-to-one communication. Sometimes it's a service-orientated communication where we need, where we send our data and we need a confirmation and we are sending out a request and we get something back, right? Sending a recipe. Sometimes it's just where we push our data and we just, it's a fire and forget. We just want to inform somebody, and if he's not getting or losing one message, don't care, the next message is coming anyway. So there are multiple different scenarios, and OPCA is the beauty to allow standardizing information and then having an end-to-end communication over all different combined transport and communication pattern mechanisms. The standardization of the information itself is the key for the digital transformation because it allows to reuse information and be aware of the meaning of the data instead of having additional agreements and contracts. Remember the old Modbus dates where you had to agree with your partner, with your communication partner, what is the meaning of the data. Instead, we have a self-describing pool of information and data sets, and this is exactly what we say, it's the semantic of the information. It's one of the 3 pillars where the promise of industrial secured interoperability is built on. Diving a little bit deeper, as I mentioned before, the OPC UA technology is something like a collection of Lego bricks where all bricks have a specific dedicated job and aim to do. Sometimes it's discovery, finding other communication partners in the web, where we have the presentation tomorrow from Jim Lewis. Sometimes it's about security, what we had as presentations. It's the transport over different protocols. So it's a huge number of different Lego bricks. And honestly, you never can say, for this specific functionality, for the PLC, I always need this fixed set of Lego bricks. it might be different if the PLC is running and controlling a robot and you need hard deterministic real time, or if the PLC is just running as a non-deterministic loop in a cloud to just control from time to time the temperature of a building. So the number of Lego bricks you need for your application, also maybe a better example with an MES system, is it just taking care on jobs to download into the PLC, or is it nearby the machine and near real time to answer questions and quality checks and make decisions on the next production step near real time at the machine? You also need different Lego bricks. Okay, so how do we establish interoperability? There's a minimum set of Lego bricks which are required everywhere. This guarantees interoperability, and you have the freedom to select additional Lego bricks to fulfill your solution for your application. In the world of Lego, if you go to a shop, you also find these pre-built packages. The ship, the boat, and a lot of more, where we played around when we have been young. So the aim of this pre-packaged Lego bricks is that you get a super user experience where you never fail, because all Lego bricks which are required to build this scenario, this Lego scenario, are designed and guaranteed to be in the package. And this is exactly the aim of companion specifications, where industry experts came together, and first of all they are describing and modeling: I'm a robot, I'm a pump, I'm a device for the industrial kitchen, a fryer, whatever, and not only describing the device and the functionality, but also making a list of what kind of Lego bricks need to be in this package. This is part of a companion specification. Okay, and both together, the core functionality allowing all this, but also the companion specification, the pre-packages guarantee that together with the tools checking all this functionality are guaranteeing the promise of industrial interoperability. The clear message here is also the OPC Foundation on its own can't do this. The partners can't do it on their own. We have to work together. Only together we can solve this for the industry. Good. Where do you find the list of over 60 plus working groups and results already? Please join the OPC Foundation web. You find it if you go on the About and you see the link here, and then you have a really nice category where you find a lot of these cooperations. You also find the contact partner and what is the status behind. So yes, you can send me an email and ask me, hey, who is behind the VDMA robotic group? Like we had a question here in the audience some times ago, but you can also just go there, find the partner on the web, see how many versions they already specified. Did they finalize version 1? Are they already working on version 2? You get a really detailed, great overview. But let's have a look a little bit on the first line. What I mentioned here, we have a legal framework, the MOCA, and I will talk a little bit about this, on the rules and how to start a new companion specification and a new collaboration with the OPC Foundation. You find all that information also exactly in that position in the web, and it is a good overview on the definition, what is a joint working group, because we are not doing a companion specification with a dedicated company only, or with 2 or 3 companies only. This is for us not a joint working group. A joint working group is always that we cooperate with another multiplier, with another association, and they are the roof of experts, industry experts for a specific domain. We will have multiple examples of that later on today, and you find them also here on the web. Second, there's a criteria where we want to check, for example, do we have already a group? for example, we have a group who started successfully and delivered already on robotic information models. If another group would come and join to start on these activities, we would link them to the existing group and ask them please to cooperate. Maybe the new group has additional ideas how to extend the version what has been done already. We want to avoid overlapping information modeling and always to start from scratch because it has not been done by me, right? Not designed by me is one of the sometimes the biggest blockers, and we want to try to bring people together, agree on something, because we believe then the acceptance of a standard is best in the world. There's also in this area on the web you find a good guidance how to create a new collaboration and contact the OPC Foundation. Obviously we are helping, no doubt about that, but there must be an idea and there must be an initiative group to think about this is exactly what we like to solve. This is the package of the Lego bricks we want to work on, and hey, OPC Foundation, can you help on this? We are all mostly technical orientated people, same as myself, and we want to solve immediately going down into the definition of the semantic and the modeling of something. This is the XYZ coordinates and global positioning. These are my laboratory analytic devices. This is my robot and so on. And sometimes we forget that there are three parts being required for standardization. It is not only the technical solution, which is hopefully then solving something which helps in the business. Otherwise it does not make any sense. And it's just a little bit entertainment to do something because you can, but nobody is using it. It also has a legal impact. And so in the focus, in the center of all of this, this is where standardization is happening. And so I like to talk a little bit about this because I believe the OPC Foundation made great homework here. We designed with all our experience of 60 plus collaborations, we designed a framework which we signed with all of them because we want to guarantee that everybody can use the results, the companion specifications later, free of charge, public available. And so we have to agree on this and also protect our members and implementers. This is critically important. We are protecting implementers to use this technology. And so we are agreeing on joint working groups on a so-called MOCA. It's the Multi-Organization Collaboration Agreement. It is public available on the web, obviously. And then it is very short. It has three parts. There are two parts on the MOCA agreement itself and the signature page where all the collaboration partners, the other associations are signing. Then it's about 3, maybe 4 pages. It's the charter. What is this group working on? What are they solving? This is a technical part. This is where most of the engineers like to focus immediately on and start. And then we have a 2-page just to be sure what is the version of the OPC Foundation IPR policy. But it is, please remind that the OPC Foundation is not the only owner of the results. The partner associations can also republish the technical work, even with a different title page, to fulfill the needs of their organization and their members, sometimes even with a different number of the version, not a version, a different title, and republish that under their roof. But the content, the technical content, obviously is identical. So again, the MOCA is what we sign with other associations to create new content. But we have a second document, and this is the called BOCA, the Bilateral Organization Collaboration Agreement. This is not to create new content, this is to share existing content if we want to cooperate with other associations. We started this BOCA agreement when we wanted to much closer work together with the OPAF forum under the roof of the Open Group in North America. And it was a pleasure for me to meet Don Bartusiak, who initiated this and is super active in this group. And we thought, hey, yes, we are working on this, and unfortunately I can't share your details because this work is still under development. Remember, once specifications are released, they are public for everybody and free of charge, available for download. But while they are under development, they are just internal in that working groups available with the cooperation partners. So how to avoid that groups start maybe on double standardizations? This would be completely nonsense. We want to avoid any double standardization. It just results in conflicts in the industry later. This is what we wanted to avoid. And so I'm glad we had this so-called BOCA agreement where we are able to share internal documents with others, with another association, without seeing this as a contribution to their IPR policy. And this is what we signed already with other partners, for example, not only with the OPAF group, but also with the Z4E, because we want to share early information. What is the status of our work with deterministic data transfer in the field level communication group to their group, because they are working and focusing on 5G. Good. If you want to get information on a much deeper focused legal information level, which I unfortunately can't deliver, then please join our presentation from the OPC Foundation Legal Counsel. It's Brad Biddle, and he made an easy to understand, for engineers, easy to understand presentation, and you find this presentation on the OPC Foundation YouTube channel. Before we start, I like to give a short introduction that creating a huge number of companion specifications is not enough. Because we realize that immediately different groups are thinking on identical topics. Multiple machines and assets need an energy management interface, OEE data. What is machine identification? So you have multiple topics where you believe this could also be useful for other organizations, other working groups, joint working groups to work with. And this is exactly why we have a so-called harmonization group under the roof of the OPC Foundation, where every leader, every chairperson from each working group, from each joint working group, is automatically a member in this harmonization group. This is led by Dr. Wolfgang Mahnke, who is doing the presentations later today. And he is exactly checking and harmonizing, can we reuse something? Do we have already overlapping stuff? Can we resolve it? This is quite interesting and quite challenging. It's the master class, the champions class of semantic standardization for the best of all of us, because if something is reused in multiple areas, you have the USB connector experience. You connect to a machine and you find immediately same basic function blocks again to communicate with, to find them easy to use. The VDMA has also an internal harmonization joint working group. This is the OPC UA for machinery, where we also get a presentation today. The VDMA have so many joint working groups together with the OPC Foundation that a pre-harmonization definitely makes sense. But obviously the OPC Foundation and VDMA guarantee that the two harmonization groups are working extremely close aligned together. And the reason behind is that also this group has involvement with Dr. Wolfgang Mahnke, so he is in both organizations involved in these harmonization groups. Okay, before I start again, this is the landing page if you want to learn more about these joint working groups where we cooperate with other partners. Just to make one more comment, and I hope I'm not confusing all of you now. Obviously, we also have internal OPC Foundation working groups. So if a couple of OPC Foundation companies come together and say, we want to standardize on a specific field, a specific area, then we can do this also if a significant number of companies come together with a goal to specify and standardize on something. This is what we call a working group, but it's not a joint working group. Okay, with all this information, I think I covered all of the topics I promised. If not, please send feedback or ask questions. That was my presentation, and we are looking now to the next presentation. Thank you, first of all. Good. The next presentations are, for me, super interesting. I know a part of the presentation because it's about the LATS the LATS standard. It has been initiated by the association Spectaris, and then also the VDMA joined as a co-owner together with the OPC Foundation. The group started working on interoperability for laboratory analytical devices. We will hear from Matthias Arnold in a second what they have done, and I can tell you Matthias did an amazing job already. He's not only a deep expert on OPC UA, meanwhile, he and Spectaris and other people behind managed that this group extended the ownership with multiple more associations around the globe in Netherlands, Spain, Japan, and maybe my list was not complete, and Matthias Arnold will give a better overview. But today it's a combined presentation because we are also today announcing a new working group. It's not a joint working group, it's a working group where OPC Foundation members came together and said, we think that we want to work together. We want to standardize something here on the market with a broader scope. And this is where Heiko Fessenmayr from Agilent will give us a presentation in cooperation with Matthias Arnold, because they are working closely together. This is where you see that the OPC Foundation is a fantastic neutral ground to bring people together, bring associations together. Even they work on a little bit a different focus. They are working together to align, to have good solutions for the industry and for all of our users. With this introduction, Matthias, again, it's a pleasure to have both of you here. I hand over to you.
Stefan, thank you very much for your kind introduction. Dear audience, hello and welcome. I'm Matthias Arnold, Technical Lead of the LATS OPC UA Joint Work Group. In the next 30 minutes, my colleague Heiko, the chairman of the CAISI work group, and I will introduce you to the upcoming OPC UA companion specifications, which will finally enable and support the digital transformation of the lab. LATS, the common language for laboratory and analytical devices, and CAISI, the standard for integration of complex analytical systems into data systems. A brief overview of what we will be talking about today. After a short introduction, I will give you a brief overview on LATS. After that, Heiko will introduce CAISI. We will end our presentation with a short statement on why both groups have chosen OPC UA as the foundation for their specifications and outline how LEDS and CAISI will play together to finally enable and support the digital transformation of the lab, including a roadmap. What is the current situation in the laboratory analytical domain with regards to digitalization? In a typical lab, you will find a mixed assortment of highly specialized devices, provided by very different equipment manufacturers. Some of the vendors highly specialized and small, some of them with a very broad portfolio. These devices produce data, such as analytical results in a variety of data formats, ranging from text-based formats like CSV to XLS and PDFs, and very often vendor-specific closed formats. However, when it comes to standardizing data formats, there are few glimmers on the horizon. Allotrope, ADF, and Animal, to name two prominent examples. But what about device connectivity in the lab analytical domain? The current situation is somewhat reminiscent of the dark ages in automation before the introduction of OPC. Different communication interfaces, if any at all, a lot of them still with serial interfaces talking vendor-specific protocols with very limited documentation available. Modern devices might have USB connectors or even some Ethernet capabilities. However, when it comes to open standardized protocols, you're 90% in no man's land. The current situation is hindering digitalization in the laboratory and analytical domain, or as Joachim Richard, Vice President Competence Center Analytics BASF, vividly puts it, no standards, no digital transformation of the lab. True integration requires more standardization in the fields of communication and data exchange. So we urgently need standards. That's the reason why we founded LEDS and CAISI. Heiko, could you please give us some more insights?
As Matthias mentioned, two areas of standardizations are needed. Let me briefly introduce myself. My name is Heiko Fessenmayr and I'm the technical chairman of the working group specifying CAISI. I've been working for over 20 years at Agilent in the software informatics division and currently in the role as an R&D lab informatics system architect responsible for the standardization efforts like Allotrope and OPC UA. Here selected standardization activities for the lab. LEDS and CAISI will contribute to the IoT communication standardization, and we will come to the specifics of both in the next slide. The area of standardized data formats is addressed by other efforts, and I just wanted to mention here the Allotrope Foundation, the ADF format as one example. But there are also others. We are seeking to support such standardized data formats as part of LEDS and CAISI. Few words on the focus of LEDS versus the one of CAISI. While LEDS focuses on standardized communication between all lab devices, here shown with the blue squares, CAISI focuses on analytical hardware integration into chromatography data systems, here shown with the green squares. So there is a linkage between them in the area for the analytical instrument drivers, where both LEDS and CAISI OPC UA interfaces will be supported. Both will also support the OPC UA DI, which means the device integration interfaces. With this, let me give back to Matthias, who will tell you more details about LEDS.
LEDS, the common language for lab and analytical devices. We are all aware that connectivity is hard to achieve in our domain. It is hard to establish plug-and-play interoperability between the many different lab and analytical devices on one side, and all the different applications like SCADA, LIMS, ELN, data asset or service management on the other side. The LEDS OPC UA joint work group tries to overcome at least some of the obstacles with an OPC UA companion specification that addresses some of the most important common use cases in the laboratory domain. These are the most important use cases we identified. First, remote monitoring, alarms and notifications. This is the foundation because if you can't see what is going on, you cannot decide or act. Monitoring is complemented by remote control, so you can start or stop functions, change parameters or set points and so on. The remote monitoring and control use cases are the foundation for automation. Second, program management and orchestration. For example, listing all the program templates on the instrument, selecting a program to be executed, starting a program run, monitoring a program's progress, and so on. During a program run, most devices, especially analyzers, generate result data. This data usually resides on the instrument before being uploaded to an application. The program management and result management use cases form the basis for orchestrating instruments along workflows. Third, the use cases required for asset management, such as condition monitoring, maintenance, service, calibration, validation, and so on. And put in a nutshell, let's support the use cases, automation, orchestration, service, and asset management. But how can LETS fulfill its promise of interoperable connectivity? We are facing several challenges. Heterogeneity. There are several dimensions of heterogeneity in terms of device types, vendors, functionality, complexity, mode of operation, and applications. Plus future-proofing, how to specify a protocol which is suitable for future device types and their functionality. LETS introduces two concepts to master these challenges. First, the device type agnostic modeling principle. It starts by considering a wide range of different device types with the goal of identifying common information patterns and building rules. In doing so, the number of patterns and rules should be limited to a minimum by being as generic as feasible, but still being able to serve the use cases which we address. Why limit the number of patterns and rules? Simply because somebody must implement all that stuff in the end. Okay, now we have a generic standard with abstract patterns that serves a wide range of different instrument types and is future-proof. But how can we tell that instrument A is a bioreactor, for example, instrument B is a centrifuge, and instrument C is an HPLC? Quite simply, by providing additional information about context and semantics, all the way from the metadata provided by OPC UA information models to referencing external taxonomies and ontologies, like the allotropy, for example, utilizing the OPC UA dictionary reference technology. How does LETS device type agnostic modeling look like? Let me give you a short example and introduce some high-level LETS patterns utilizing two distinct instrument types, a centrifuge and an integrated HPLC. Although the instruments are different, they look very similar from a LETS connectivity point of view. They are both devices with their nameplates. Their hardware components are modeled in a subtree called component sets, each component exposing its individual nameplate and maintenance relevant information for condition monitoring and so on. The functional unit, the yellow box, provides the functional view on the instruments. One device could expose more than one functional unit. For example, consider a parallel bioreactor system where each individual bioreactor is modeled as a single functional unit. Specific functions are organized in the function set, the green box. For example, in case of the centrifuge, the agitation controller, the lid controller, the temperature controller, and so on. Device level orchestration is represented by the program manager, and it works exactly the same whether the device is a centrifuge or an HPLC or a bioprocess controller or whatever. Bottom line, over the network, the instruments look pretty much the same. LADS enables plug-and-play interoperability for lab and analytical devices through device-type agnostic modeling. Where are we today with LADS and what are our deliverables? Let's look at the LADS roadmap. After defining the use cases and the high-level concepts, we started the implementation of the LADS proof of concept. Within the proof of concept software, we create a growing number of simulated devices, exposing their data in information models in accordance with LADS patterns and building rules. This allows us to test and optimize the concepts as well as identify gap and missing pieces. This proof of concept turned out to be a very useful tool, and we continue improving it. Currently, we author the first draft of the LADS companion specification. Once this approaches a stable state, we will start to create reference implementations for clients and servers. We expect to release the LADS companion specification in its first version somewhere mid of 2023. Following an agile approach of build, measure, learn, we test and verify our concepts during LADS hackathons, which take place approximately every 6 months. How are we organized? LADS is set up as an OPC joint work group. Founding members include a group of device vendors and the OPC Foundation, VDMA, and Spectaris. Spectaris, the German-based Association for Analytical and Lab Technology Vendors, formed the initial nucleus of LADS. VDMA is instrument in cross-harmonizing many OPC UA-based companion specifications for several industries. In addition to the steady growing number of device vendors, other associations joined LADS, such as Gambica, LabMass, FHI, or JIMA. Our user review committee, the LADS ERG, provides valuable feedback with regards to requirements, prioritization, applications, use cases, and so on. Members of our hackathon group, the LADS Hack, implement LADS into their real-world devices and applications, plus share information on tool chains, technologies, and best practices. The setup is complemented by regular exchanges with peer foundations in our domain, like Allotrope and Bioforum, for example. Finally, the ongoing harmonization with other OPC workgroups avoids redundancy, fosters synergies, compatibility, and reuse. If you want to participate in LADS, join us, be the next. With LADS, we will achieve plug-and-play integration of laboratory and analytical devices along the workflow. In the next minutes, Heiko will introduce you to CAISI, which aims at integrating complex analytical systems which might be composed of multiple devices into data systems.
Now let's switch over to the CAISI OPC UA companion standard, which stands for Common Analytical Instrument System Integration, and this specializes on integrating analytical instrument system into data systems, for example chromatography data systems. This companion standard is created by the ASI working group, that stands for Analytical System Integration Working Group. Chromatography data systems have to integrate different vendors' analytical devices. And so far each vendor has its own proprietary software architecture. The integration and wrapping of other architectures has always been a significant effort, and on top, the current interfaces were not designed for modern area and modern IT infrastructure. Examples are web user interfaces and cloud architecture. Agilent, Shimadzu, Thermo Fisher Scientific and Waters, which represent the majority of the analytical liquid chromatography market, started in 2021 an evaluation to create a common industry standard to ease such an integration. And the goal was to base it on a long-term stable standardization framework. In October 2021, these companies decided to base that standard on OPC UA and to establish an OPC Foundation working group and to start working on CAISI. And finally, the kickoff for the working group and the CAISI standard is planned for May 22. The charter given to CAISI is to be independent and an active industry standard for interoperability of analytical instruments with data systems. It shall support plug and play to reduce or eliminate today's software-hardware interoperability issues, and it shall be cloud compatible. It should also allow for multi-vendor analytical instrument system composition. This means for an instrument system software, it should be able to combine a driver for a detector from a vendor A with the driver from a pump from a vendor B. It shall give analytical instruments also more autonomy and flexibility for executing analytical measurements. And furthermore, it should simplify instrument discovery, enable remote management, simplify support and analytical capabilities. Here on the left is shown how typical chromatography data systems are set up today. Let me describe this bottom up. An own vendor's device gets easily integrated into their own proprietary instrument control interface, so no adapter is needed for that. Different vendors' devices, because of their different architecture, have to be integrated using adapters into data systems. See the red circles. And data systems themselves expose their functionality and result data via other proprietary APIs and data formats to the data consumer. See the orange circle. In this example here on the left, overall 7 specific adapters are needed. For each adapter, it means special software to be written and tested for communication and data format translation. With communication and data format standards here shown on the right, such adapters will become obsolete and integration is easier and more straightforward. CAISI will focus on standardizing the driver integration. That means it will standardize the instrument system layer and the driver interfaces to be integrated into this instrument system layer. The more upper level interface between the chromatography data system and the data consumer connection, for this there is the intention to standardize this later via a separate OPC UA companion standard. During the evaluation phase, the initiating members implemented a proof of concept prototype. In this POC, basic functionality for the CAISI OPC UA interfaces for the layer between data system and the instrument system controller called LIC, and for the layer between LIC and the physical instrument control drivers called PICs have been designed using OPC UA tools and implemented via different OPC UA SDKs. Here an overview on the areas to be specified for CAISI. First, CAISI will require a broad range of OPC UA technologies, especially cloud communication is important. But you will also remark that beside OPC UA, there are also non-OPC UA technologies needed. For example, the web user interfaces to be delivered with analytical hardware drivers. Since OPC UA does not cover that area, we will require a solution based on iframes or web components or other technologies. But the good news is that even non-OPC UA specifications can be integrated into OPC UA companion standards. Also, further non-OPC UA technologies are required for specifying the data formats. That means raw data, acquisition method, or the results. It's not yet clear by now what to use, but the current data format standards like allotrope data format or others are intended to be leveraged.
When we started the Let's initiative, we did not want to reinvent the wheel. We wanted to build our work on a proven and secure foundation. So why did we choose OPC UA? Because OPC UA is secure. This is a must-have nowadays. OPC UA is proven. It is the de facto standard for process industry, pharma, and many other industries. OPC UA is platform independent. It runs from embedded microcontrollers all the way to cloud-based infrastructure. OPC UA's unique information modeling capabilities is where it really shines. Information modeling is key for plug-and-play interoperability. OPC UA is a true and open standard which speaks for itself. And last but not least, OPC UA's cloud support grows fast. This is an evolving requirement for the laboratory and analytical domain. Heiko, what are your criteria for choosing OPC UA?
Why has CAISI decided to go with OPC UA? First, the CAISI shares the same needs as shown for LATs before. For the CAISI initiators, it was most important to look at the criteria listed here. The standard has to be a real industry standard with a standardization body and a strong community. OPC UA fulfills both. We also found the OPC UA information model to be sophisticated and standardized. Another important criteria was regarding adoption and acceptance. And there we found that our customers in pharma, chemical, oil, gas, food, beverage already use OPC UA in their manufacturing today, and this worldwide. Technology-wise, it was important to us that the standard is not wired to a single technology. OPC UA has shown with their layered framework that they can pick up new technologies without affecting existing software code. For sure, a cross-platform support is crucial. Regarding cloud capabilities, OPC UA today has already a good support for PubSub telemetry data, but we also require for the cloud a bidirectional session-based exchange. OPC UA WebSockets are specified today, but we are looking forward to get a broader support for this in the SDKs. Overall, we still need more insight into the various options of an OPC UA-based cloud topology. As there is some linkage between LATs and CAISI, a close collaboration and harmonization is important. Both working groups have agreed to collaborate closely and to make sure that the two standards play nicely together and do not overlap. Both activities have industry support by major players in the lab domain. That means end consumer and solution providers. And with their close collaboration, LATs and CAISI will build a foundation for the digitalization of the lab and the analytical domain. Finally, what are the planned roadmaps for LATs and CAISI? In the upper part you see the LATs roadmap, in the lower part the CAISI one. LATs is further ahead since they have already started in 21, and for LATs there are 2 hackathons for software implementation planned per year. A first early draft of the LATs companion specification is planned for the second half of 22, while a first official LATs release is planned for the second half of 23. CAISI is about to be kicked off in May 22. And the CAISI companion specification and the prototyping will be executed in an agile approach. So while we have already outlined the needed scope on a very high level during the evaluation phase in 21, we need to drill down in more details. Therefore, end of 22 is planned to have an overview of the big picture of the OPC UA CAISI information model and how to slice the work over the years 22 to 25. End of 22, we also plan to have a first subset scope specified, and the prototype for this scope is demonstrated. In the years 23 to 25, further subsets of the CAISI scope are planned to be released. In Q1 25, we plan for the latest date of the final release for the CAISI companion standard. So now we are at the end of the presentation, digital transformation of the lab through upcoming LUTs and CAISI OPC UA companion specifications. If you have questions, please leave them in the chat, or we are also happy to answer questions in the Q&A session. Thank you for your time.
Wow. Thank you so much for that presentation. I'm deeply impressed. It's amazing to see that we are growing out from the core where everything started in the factory floor. We are growing into new markets. And what I realized with your presentation, growing into new markets also means we have to fulfill new additional scenarios, and we need additional functionalities to fulfill them. Heiko clearly addressed this is what we are using, and which is great from the OPC UA technology, and this is what we have to do on top. This presentation was clearly structured, perfect messages, fantastic milestones clearly addressed. So good luck, the new working group, CAISI. Matthias, perfect to continue on that way, and we all together will have multiple more presentations on the progress, also on different shows, trade shows like the AixEnginners later the year and so on. Thank you so much. With the next presentation handing over, it's now Suprateek Banerjee from the VDMA. And remember, the VDMA is one of our key partners because round about the half of all information models from the OPC Foundation are in cooperation with the VDMA and the members. So there was a huge initiative driven by the members in the VDMA to come together and standardize the information models first, which at the begin had nothing to do with OPC UA, but for sure they selected for reasons the OPC UA technology because of everything what we have explained multiple times, the openness, the IEC standard, security, independence, and so on. So right now we will get a new information from SUP, and I'm listening and hand over to you.
Hello, and a very warm welcome to the Relative Spatial Location subgroup update on Day 3 of the OPC Day International. This is Suprateek Banerjee from VDMA Robotics and Automation, and I'm glad to present you the OPC 10210 Relative Spatial Location specification. So let's jump into the introduction or the concept idea behind the specification. The specification provides a few types which can be used as OPC UA add-ins. These add-ins can be added to instances in an OPC UA address space to bring these objects in a spatial relationship with each other. All systems that need a relative spatial location description for the objects of interest can use these add-ins in a standardized way. As the geometrical setups of systems can be very diverse, this specification provides a mathematical definition including examples of how to use the concept in the informative annex section. This brings us to the scope of the specification, which is an OPC UA information model for the representation of relative spatial locations of objects. The concept is based on the transformation of coordinate systems with the help of frames, which are typically used in robotics or vision systems to describe and calculate the location of an object or its position. Let me quickly give you an overview of the information model of the specification, and then we will jump straight into an example to show the usage of the concept. Here you see the spatial location type containing three variables: namely position, orientation, and base. This is an abstract type to describe the position, orientation, and base frame of reference of a particular object. Notice that the variable base accepts only node IDs as its values, as it will be used as a poor man's reference to the node representing the frame of reference for this object. This specification also defines a concrete subtype of the spatial location type, that is, the Cartesian frame angle orientation type, wherein the position has been defined following the Cartesian coordinate system and the orientation has been defined as angles representing roll, pitch, and yaw. A system of objects describing their own relative spatial locations is represented as a so-called spatial objects list, which is of spatial objects list type, containing an identifier for that system of objects and the origin or the world frame for this system of objects. All spatial objects in this system will be directly or indirectly linked to this world frame. Whenever a new object is added to or removed from the system, a model change event is generated. A spatial objects list organizes one or several spatial objects which are of spatial object type. This is the type that can be instantiated and added as an add-in into existing instances of an OPC UA address space. The spatial object type has an identifier for the spatial object, a position frame which accepts any concrete subtype of the spatial location type, also shown on the previous slide. It contains a folder for attach points which organizes all spatial locations with respect to which other objects may be attached, a folder for the internal frames of the spatial object, and a folder for the alternative frame chains, which we will see in the next slides. Let's begin with an example for you to familiarize with the terms used in this concept. Let's say that we have an empty room and the purple frame is the origin or the world frame for this room. Derived from the purple frame, there is a green frame, which is the position of this table. Now let's say that this corner of the table will serve as an attach point with respect to which other objects can be placed on the table. For example, this chessboard. The green frame on top of the table represents the position frame of the chessboard. Similarly, you can imagine 64 attach points on the chessboard. This brown knight is placed on one of the attach points, but its position frame is oriented a little differently. Similarly, this white king is placed on another attach point with an offset. And this brown king is placed exactly on top of another attach point. This brown queen is out of the game and is lying freely on the table. Therefore, its position frame is represented with respect to the attach point of the table. You can also see small attach points on the heads of these figures, with the help of which these figures can be dragged or picked up by another tool. Now let us try to model this table with the tools provided to us in this specification. Note how the specification uses the constant bit in the axis level X attribute of the nodes. If the spatial location of an object itself is fixed, then the constant bit of the variable representing the frame itself is set to true. To denote that the frame of reference is fixed, the constant bit in the variable base is set to true. This is represented like so in the model below. Constant is for the frame itself and constant base is for the frame of reference. Considering this table as the system, here you see a spatial objects list representing the system with the world frame, that is the purple frame, as the origin of the system. This table has a spatial object add-in which describes its position frame and its attach points. Note that since the world frame is the origin, it has no frame of reference. Therefore, the base variable of the world frame must be null. As you can see, since the attach point is defined with respect to the position frame of the table, which in turn is defined with respect to the world frame, this relationship can be established by following the poor man's reference, that is, by hopping to the nodes mentioned in the base variable of the respective frames. These chains are shown in green. Here is the complete model of the example shown earlier. All objects in this system describe their relative spatial locations with their respective spatial objects. Each spatial object describes its position frames and attach points. Let us understand this from the perspective of the white king. The white king has an attach point called head, the position of which is with respect to the position frame of the white king. The position frame of the white king is described with respect to the position frame of the chessboard. The 64 attach points of the chessboard has not been represented here for the sake of simplicity. Now, the position frame of the chessboard is defined with respect to the attach point of the table, that is the table corner, and so on until you reach the end of the chain, that is the world frame. It is important to note that in addition to the attach points, the white king also provides an additional way of representing its spatial location, that is, directly with respect to the world frame. And this is exactly what is represented in the alternate frames folder. This is another example to show the usage of this specification in a multi-server scenario. Imagine a scenario where you have an OPC UA server for the chess room with 2 playing stations in it. You also have 2 separate OPC UA servers for each of these playing stations with their own chess tables and their own world frames. This specification gives you the possibility to relate the different spatial objects represented in the different servers. This is where the identifier comes in. Note how the value of the identifier of the spatial objects list in this server is the same as the value of the spatial object in this server, thereby meaning that a whole system of objects that is represented by the spatial objects list in case of this server is the same of the spatial object of a single spatial object in this server. Hopefully it is not so difficult to see how this same concept can be used in an aggregated scenario with multiple levels of abstraction, just like in this example. Now I would like to give you an overview of the use cases supported by this concept. The concept supports building of frame chains describing the placement of objects in space based on common or different reference coordinates. The concept supports identification and mapping of reference coordinates usable for controller-to-controller process communication, for example, a robot with a machine vision system, or which is usable for aggregating server scenarios. The concept supports dynamic aspects to enable a client to be aware of changes in the relationship of objects, or when objects dynamically appear or disappear. This concept can be used to describe the relative spatial relationships of each object which is based on some reference coordinates. the definition of each object in space is self-contained, describing its location related to that reference coordinates. Well, that's it from my side for today. In case you have questions, you can shoot them right now, or you can also contact me at the contact details that you see on the screen right now. Thank you, and have a very nice day.
Suprateek, thank you very much for your presentation. That was enjoying, having chess as an example to explain it. Fantastic, but I also was astonished, and it reminded me in my very, very old days where I studied electrotechnics, also a little bit on robotics, and we were calculating the transitions from the absolute to the relative coordinates. At that time I was able to understand, maybe I lost this knowledge meanwhile, or the mathematical calculations behind. Okay, thank you so much. I'm glad we did this day. We designed the day to talk about these collaborations and get a deeper dive into these different areas and markets, because just having an overview would not fit to this exactly. With this, I am announcing the next speaker, and it's Dr. Matthias Jöst from the association omlox. And we are going to have a joint working group soon, and this is where he will talk and introduce this idea. And now I'm a little bit interested on, okay, how does it fit to what we heard earlier together in the global positioning here in a seamless way in different areas, the intralogistics, the production area, where you also need a global positioning to find assets and find specific positions. Matthias, I'm handing over to you.
Today, and yeah, I'm happy to continue the discussion and presentation from SAP on relative location. Now in my session we are talking on a global world frame, so to speak, and how to define where things are on a, as said, global scale. But first of all, a few words to myself. Yeah, oops, that was too far. 1 second, give me a second. So, no, seems, yeah. 1 second, yeah. Now, yeah, here we go. So, who I am? I'm Matthias. Yeah, and that is also a great thing of the OPC Foundation, that many experts from different fields join in to define how industry is being built in the future. So I have a background in geoinformatics, so I'm not an industry folks. I'm dealing with location-based services, with navigation, mapping, finding things. I run a sort of small software company. I joined OPC or my company last year, and I'm also committee leader for omlox. Omlox is a locating standard that is hosted by Profibus. I think most of you might know this association, coming more from the industrial communication field. And we in omlox take care how location data is processed and generated for moving things. But that's only one part of the game. And as Stefan also mentioned, we need to have collaborations. We need to get the data flowing from A to B in a seamless manner. And therefore, yeah, we are engaging also with OPC to work on a global level. And yeah, so, and the background of all of this is, of course, everything moves in production, in logistics. We have seen the world frame, the relative spatial location example that SAP has mentioned, but of course, a world frame, so in this scenario, is somehow located on a globe. And we are not only in buildings, but we have seamless scenarios. So robots are moving, robots are mounted on an AGV. And so everything is sort of flowing, and therefore it's important to know where things are. And my little presentation today has 4 little aspects. So I want to talk on the use cases, why this is needed. I'm going to give you an insight how location is being defined in the different OPC specifications, and then I'm going to argue why we need to have to align this and have a global perspective that everything works nicely together like Lego bricks, also from the location perspective. And then I'm going to talk on the initiative that we are about to start in the upcoming weeks, so that you are invited also to join in to contribute to this new endeavor that we jointly want to do. So location use cases. I think these days we all experience that location is an important topic. We experience supply chain differences or difficulties. We experience lack of goods. We experience also in pandemic times knowing where people are, how many people have been in a room, who met whom. So location is very ubiquitous. And of course, in industry, there are many use cases that deal with location data. Of course, one no-brainer is asset management, finding things somewhere in a production site, in logistics. On the one hand, to optimize processes, to automate, but also to use assets more efficiently. And that has also some aspect on sustainability, decarbonization, CO2 footprint. So using assets efficiently. And of course, when things are moving, logistics, the location changed. Also there are a lot of use cases in warehousing, in intralogistics, in supply chain management, you name it. So there is a huge bunch of use cases. Then, of course, machines need to be operated, maintained, and also there you need to know which machine you are maintaining, where to go, how to find them. Also there are a lot of use cases associated. And of course, we all aim to automate things, on the one hand, to be more efficient, but also lack of labor, finding educated people is a challenge in many countries, at least these days, and therefore also automation tasks are relevant. And when things are moving, of course, a digital system needs to be aware that something has been moved. So, for example, in the warehouse management or in the production planning or in the enterprise resource planning. So you need to transfer the movement to a digital system, and therefore all these manufacturing execution systems, they need to be aware that something happens. And the challenge now is for in real life, of course, many different applications, different devices, different locating technology, especially indoors, different wireless technologies. So it's sort of a huge mess, and we need to work on that. And with omlox, we try to solve the aspect on how to get the location data. And now, jointly together with the OPC and AIM, another foundation that joined in, we're going to define how the data is then processed, used in alignment with the already existing specifications. Stefan also mentioned the harmonization working group. So there is something that we need to take care that everybody has the same understanding. And location data, there are different approaches how to get to location data. And we have seen in sub-examples, we have the relative location aspect. So you can define a location relative to another location, like the frame example in the robotics use case. And of course, you can somehow have a global perspective, or even, as you see on the picture, an even global, more global perspective to define in a coordinate system, for example. And then we can define locations geometric, with positions, with vectors, with coordinates, or semantic. A thing is left to another thing or on top of it, which has some meaning, especially to the viewer, to the one who is managing a system, to us humans. So there are different approaches how to define things. And what we're now going to do or aim for is to work on a common understanding of everything that is somehow oops, why this is not going. Yeah, here we go, a little bit lag. So everything that is in a production site, we want to know where things are: a product, a machine, a robot, a tool, an industrial truck, an AGV, and drone. Also, as humans still being on production sites, so that we know, or things know of each other, especially if production is getting more and more dynamic, and also logistics is getting more and more dynamic. We have more and more AGVs, robots moving around, so a common understanding is necessary from different perspective, of course. And yeah, that is the aim of this initiative, to come to an holistic understanding, to allow also for a seamless locating outdoors, indoors, so that there are no barriers when locating. There are no technical barriers, but also from the semantics and understanding, there are no barriers, and every stakeholder in this production industry domain can understand who is neighbor, where are things. So to have this holistic view, that is the idea and the concept. And of course, location is not new, also not new to OPC, and there are a lot of specifications, either core specifications or complementary specifications, that already deal with location data. So this initiative is not starting by zero. We have something that we can work on, that we can refine, that we can adopt. And yeah, so here you can see a list of examples, and there are even further in all the companion specification, or in many, some location aspects are touched, even in this laboratory environment. Also there, location is an aspect when you have these laboratory use cases. But for the time being, I will concentrate on the general information model. Also, Sub has mentioned this already. Then the machinery part, then a companion specification that is even more precise, and yeah, other location specific or companion specifications where location is being touched, the relative spatial location have been seen, and I think Manfred will talk a little bit on asset management, where also location plays a role. And yeah, in the general information model, we have this XYZ coordinates being defined as Cartesian coordinates, having means in a Cartesian space to define things. And of course, when the first locating use case has been started, one had the more indoor use case in mind, having a production site, a hall, where you have a certain point where you can start to refer to, and then compute locations in this coordinate system, in the Cartesian coordinate system, according to this hall or to this space. And in order to complement those, the vector, the 3D vector is defined, and also some orientation, and also a framing where you can assign a certain frame to a position and its orientation. So as said, in a given space, define where things are, and the relative spatial location subspecification have used this schema to refer to things in a relative environment. And then on the opposite side, we have a companion specification where location is just defined as an arbitrary string that can be, as you see in the example, Munich A2 217. This could be a city, Munich. A2 might be a hall, and 270 might be a certain area. So there is semantic associated, somebody who can read this and knows the location, knows where this thing is. But of course, if you want to compute something, this is quite hard to come to a common understanding. Having the understanding in Munich could be Munich, the city in Germany, but I'm confident there are also other cities that might be called Munich in the US or in other places. So it's not free of ambiguity to see and compute with this. So that's the other spectrum that we have. And then a couple of years ago, with the support or from the Auto ID community, we have a companion specification, or OPC has a companion specification for Auto ID, and there the use case is identifying things on shop floor or in logistics, especially with OCR systems, with RFID, for example, with camera-based systems, and those Auto ID technologies have been, or typically are used in also on the one hand in production, in line-based production system, but also a lot of in logistics, especially for pallets and larger goods where you want to identify a bulk of things. And therefore, in this companion specification, we have already a first understanding on a global schema, and that is defined here. We have data type, which is VGS84, spatial reference system with a latitude and longitude definition on a global schema and some altitude. And so you can see already there is an aspect being touched. And then in the new relative spatial location, we have this framing schema, and in the asset management, we have also a certain element already been defined about hierarchies, where things are, whether a thing is in a certain area. So my message for this block is already in OPC, there are many locating aspects being touched, and with a certain background, with a certain purpose, but to our understanding, an alignment is needed, and also an extension, and that is what I'm going to tell you in a minute. So having a global coordinate system, and you see here the picture of a map and the compass, and how people have been navigating around the globe in anxious time. It's a challenge to identify locations on the globe. If you want to have a high precision, and in some scenarios, the global coordinate system, VGS84, or satellite-based position system, is not enough. And here is a short visualization where you could imagine that, we are living not on a ball, which is ideally a round shape. We are living on, or a little tiny planet is, in geoinformatics, one would call a geoid. So it's a certain type of shape. You can see here this video from ESA. They did a 3D scanning of the planet. You see the different land masses, you see the water, and this thing is not round. And so having a positioning system that matches this thing is a challenge. And why it is? Next slide. You can see, already 100 years or many years, people trying to describe this planet where we are living on a flat plane. And there are different means to do this. You can see here some examples. You have a cone, for example, or you have a blade, and you are projecting the Earth's surface on a flat plane. And when you do this, you have always certain deficiency, something that is not working right. Either it's the angle, it's the distance, or the area. And so you have always to deal with the fact that not for every place on the globe, everything is matched accordingly. And you might have seen in the past some pictures of the globe where Africa is as large as Greenland, and Russia is larger than Africa. In reality, this is not the case, but due to these projections, it appears to be, and of course, that has some impact, and especially if you are in high precision industry scenarios, where it's about 10 centimeter could be damaged or hurting somebody, or a robot is putting something on a pallet. So the global reference frame should be in the right setup. And on a global scale, we are doing this with this VGS84. I don't know why this picture is not shown. Here it's going, where we divide the globe in certain latitudes and the longitude, and you have certain spaces and coordinates where you can pinpoint where things are on the planet. And this is for many logistics use cases. It's widely adopted. Everybody is using the GPS format to navigate, but also there we experience that GPS is not 100% precise. The satellite signals are not always being received very well, especially in urban environments. So also this type of locating system has some challenges, especially if you need high precision and 1, 2, 3 meters are not enough for the use case that you are targeting at. And for that reason, there are other coordinate systems that one can use for different purposes. We at omlox, we have decided that we use, in addition to VGS84, that is also described in this AutoID companion specification, we have decided to use UTM. That's a certain way of slicing or projecting the globe on a flat on a plane, and there you have certain type of cells that also are defined. And the positive side is that you are in a number of where when you are in GPS coordinates, you can reach 10 centimeter, 20 centimeter precision. In UTM, you can reach a precision sub-millimeter way, and therefore that's another projection that can be used for those use cases where high precision is needed. But that is not the only one, and there are even more, and therefore, it's necessary to have the flexibility to use different projections, but also to know which projections are used, to also translate between the different projections so that everybody knows what is the global reference that something is using to refer to space, and how to compute this. And therefore, as said, the idea of this working group that we are planning is to define which coordinate systems are needed for the different companion specification, for different use cases that we are targeting, for robot, for vision, for logistics, for all the others, to have a defined set of coordinate reference systems that can be used either in the relative locating use cases to refer to, or if you have systems running that always use global coordinates and follow a drone flying in the hall on the global scale, not relatively, that you are then also have the common understanding. And that is the summary and outlook. So as said, we have already in OPC a lot of touch points to location, but some harmonization is needed, and for the high precision use cases, VGS84 is not enough. We want to open this up for having other global reference systems, and for that we initiate a new working group together with AIM. They have started this GPS input in OPC already. We from omlox, as part of Profibus, we have been taking care of how to compute this location data with different locating systems, ultra-wideband, Wi-Fi, Bluetooth, and by having those different groups together, we can. I think we are well set up to define this for the benefit of all, and to come to a joint understanding. Yeah, so that was it, and hope there are some questions. If not, just reach out, and soon we will publish the corresponding call for experts, and you're invited to contribute, to join into this initiative and the working group, and shape with us how location data is being used for the global scale for OPC. So thank you.
Matthias, thank you very much, and maybe you keep your camera on for just 1 2 questions. Amazing. So it was a great presentation. Thank you very much. And I'm definitely looking forward that both of our associations work closer together and we do the announcement soon. And what I again really enjoyed is that you had a link to what are we using from OPC, but also where is a cooperation and also harmonization and cooperation with other associations like AIM or the VDMA group and so on. Perfectly. So for me, representing the OPC Foundation, acting here as a neutral ground, it's a fantastic story, and this exactly shows the needs of the industry to grow into different areas. A short question, because you're here live and you can immediately give an answer. If people want to meet you in person or get more information about omlox, there are a couple of upcoming trade shows here. Hannover Messe is upcoming. Will you or omlox representatives be in Hanover?
Yeah, we will be at Hanover Fair. Of course, there's a Profibus booth, but also I think OPC has a presence, and I will be there on the first 3 days, and I will move around and be available for meetings. And omlox is also at the Logimat, because we have also a lot of touch points to logistics. So there you could also meet some folks from the omlox community to have a chat and discuss joint activities. And therefore, yeah, there are a lot of occasions where one can meet us. We are at the IoT summit in Barcelona in May, and also in trade shows in the US. So the omlox community is quite active, and now that we are working closer together, we might have then in the future also joint activities somewhere in November at the SPSS or other occasions.
Because we
and of
also
course we have a website, and you can reach us online. So there is a lot of space where you can reach out. And
okay, perfect. So, well, then thank you very much for the audience listening here from North America. So please go to the website of omlox and find there places where the omlox people are present. I'm looking forward for the joint work together with you, Matthias. Thank you very much again.
Thank you for having me. Then, bye.
Bye. So the next speaker is again from the VDMA. I already introduced the VDMA as one of our key partners for a lot of these collaborations and joint working groups. But I already mentioned that harmonization is the champions class of cooperating with each other, aligning with each other, and finding the best for the broadest adoption to avoid any overlapping or double standardization. Therefore, it's a pleasure for me to welcome Heiko Herden from the VDMA. He is leading the OPC UA for Machinery working group, and this is exactly the hotspot of harmonization inside the VDMA, and Heiko will give us much more details. Heiko.
Hello to this year's OPC Day, also from my side. My name is Heiko Herden. I'm working at the VDMA in Frankfurt in Germany, and I'm the chairman of OPC UA for Machinery. And this presentation is about OPC UA for Machinery, how cross-domain interoperability is brought to reality. So let's take a look at interoperability. Interoperability is the success factor for the future. And as you can see here on this slide, we are coming from Industry 3.0, where we had proprietary communication, where it was really cumbersome to connect different machines to each other or to overlying systems, for example. And now we are entering the field of Industry 4.0, where we get interoperability. And we get into this field because of OPC UA and the meshed communication network it is. But furthermore, we need information models, because OPC UA is like the grammar of a language. It gives us the rules how to communicate, but on the other hand, we need to know what to communicate. And this is done in domain-specific harmonized information models. These models are worked on in the VDMA. We have about 40 active working groups writing those OPC UA companion specifications. And furthermore, we do harmonization with the cross-domain harmonized information model done in OPC UA for machinery. And only with this harmonization in OPC UA for machinery, we get the highest level of interoperability. And so in the end, we have the global production language with OPC UA as grammar for this language and with the companion specifications and machinery as vocabulary for this global production language. So this means that OPC UA for machinery is an OPC UA companion specification like the others as well, but it is suitable for the whole mechanical engineering industry and beyond. We are defining harmonized basic building blocks for the broad use, and each building block stands for a specific use case, so like machine identification or machine state or energy management, for example. These building blocks can be referenced from other companion specifications, or they can be implemented as a standalone model. So for example, if you have a machine that doesn't have a companion specification already, but you want to make an OPC UA interface, you can still use the building blocks from OPC UA for machinery. And so we could say that OPC UA for machinery forms the basis for interoperability. So let's take a look on how to use OPC UA for machinery. I brought an illustration about the target image, and as you can see there, we have OPC UA for machinery as broad basis for all the different companion specifications. And if we take a look now at a specific interface, for example, the interface of a laser machine, you will see that we use a combination of different companion specifications. So we have OPC UA for machinery as basis, then we use the OPC UA for machine tools as, so to speak, second basis. And then on top of that, we have the companion specification for laser in the future, where we have specific properties and values for this laser machine. Or on the other hand, if we take a look at the second interface, we could use the woodworking machine. And you can see here as well that machinery is the basis on the one hand, and on the other hand, we have the domain-specific companion specification for woodworking. And both together we will have in the interface. So you could say that OPC UA for machinery is the base companion specification for the whole field of mechanical engineering. So let's take a look at the current status of the OPC UA for machinery working group. As you can see here on this slide, we started with the topic of machine identification at the end of the year 2019. It was the first topic we finished, so the first building block we released was machine identification, and then furthermore we did the topics of component identification and machinery state. Both are released now already as well, and since April 2021 we are working on the topic of job management. It's a bigger topic and we will still need some time there, but we also worked in parallel on the topic of result transfer, and there we have a release candidate out since the beginning of this year until at least June 2022. Furthermore, we started the topic of energy management in October 21, but there we stopped the work because we will continue the work in the joint working group for power consumption management. I will tell you a little bit more about this in a second. And we also started the topic of process values at the beginning of this year. So in this presentation, I will focus on, of course, the group for power consumption management on the one hand, which we will start very soon. And on the other hand, I want to give you some technical idea about what we did for machine identification, component identification, and machinery state. So like I mentioned already, the topic of energy management will be worked on in the new joint working group for power consumption management. it will not only be a joint working group between VDMA and OPC Foundation like we have with OPC UA for machinery, but this joint working group will be between OPC Foundation, VDMA, P&O and ODVA. The kickoff will take place very soon on the 2nd of May. And of course, we will consider the pre-work that was done in all those different organizations. So we have Profi Energy, SIP Energy, and of course, we also started with the definition of use cases in our OPC UA for machinery group at the end of last year. So let's take a technical look now at how we solved those different use cases. Let's start with machine identification. Like I said, it's released already. And there we defined a machine identification type. And as you can see here, a lot of those parameters on the right side start with a 2 double point. And this means that those properties are inherited from part 100 devices. We did use OPC UA common models like DI to gain a higher interoperability. So a lot of groups already used the device specification before there even was machinery. And so we said, okay, there's no way around it. We have to use devices as well. And that's why you see so many 2 double points here. And if you take a closer look at those different properties, you see we have 2 columns. The column on the left is meant to be filled out by the person who is selling the machine. So these are properties that usually don't really change over the life cycle of the machine. And on the other hand, on the right side, we have the column with the 3 properties which are meant for the person who bought the machine to fill out. So for example, he wants to give the machine an asset ID or a component name or define a specific location where the machine is standing. So for example, my machine is standing in Hall A, position 4 or something like this. And most of these properties are optional, but we have 3 mandatory properties to achieve a unique identification. And mandatory is the product instance URI, the manufacturer, and the serial number. And with this building block for machine identification, I can answer the questions: what machine is it, who built it, when did I first start a machine, where is it standing, and so on, in a unified way. And this works for different machines from different domains. And so you can easily get all the information because it's available in the same way. Now let's take a look at component identification. This one is pretty similar to machine identification. Nevertheless, it has some differences. So we still have a lot of properties inherited from part 100 devices, but this time we didn't want to have a unique identification, and we have some different properties. So for example, we don't need a location because the component usually is part of a machine and the machine already has a location and it will be the same. And on the other hand, we have one additional parameter, which is the device revision. Furthermore, we only have 2 mandatory parameters. We have the manufacturer and the serial number, but we don't have the product instance URI mandatory because the component doesn't have to be uniquely identified. Together with the use case of machine identification and component identification comes the use case of listing machinery items. And as you might know, you can browse through an OPC UA information model. And if you have a server, for example, with several machines connected, like an aggregating OPC UA server, then it might come in handy that you have a standardized way of listing those different machinery items. And so let's take a look at how you browse through such a server. So you have the objects folder at the beginning of your browse path, and underneath this objects folder is the machines folder. Within the machines folder, you will find all the different machines that use the machine identification type. So you could say that the machines folder organizes any machine that provides the machine identification type. Furthermore, we have a list of all the components of a specific machine within the machine. So there is this, let's call it component folder underneath the machine, and you will find all the different components. And there might even be the special case that a machine is a component of another machine. So the next topic I want to talk with you about is machine state. And as you can see here on this slide, the current problem with the machine state was that in all these different domains with all these different machines, we had a different wording. So for example, in one domain, they said it is working. In the next one, they said the machine is running. Then there was like executing or production or dry run. And you couldn't really know if these words mean the same or if it has a different meaning. And so we had to do something. And the solution comes with the machinery state from OPC UA for machinery. Let's take a look at the machine view. If I am in my production with different machines from different domains and I take a look at them, I will see in this example that all of these machines are in the executing state. They might have a green light for this. And I know, okay, everything is fine. Or if I have the component view instead of the machine view, I might take a look at my machine and I see, oh, it's red, it's out of service, and I wonder, why is my machine out of service? Then I can take a look at the different components that are part of the machine and I will see, okay, the conveyor could work but doesn't do something, as well as the injection, it could do something but it doesn't, and the only thing that can't do anything at the moment is the gripper, and this might be in this example because this beverage filling line has a jammed gripper. And so I know, okay, the problem is this component. To achieve this use case of machine monitoring, we define two states. We have the machinery item state, which is applicable whenever the OPC UA server is running and consists of 4 states: not available, out of service, not executing, and executing. Not available means that the unit is not available and does not perform any activity. So for example, it is switched off or in an energy saving mode. Out of service means that the unit is not functional and does not perform any activity. So it's, for example, in an error or blocked. So the main thing is it can't do something at the moment. Then next we have not executing. This one means the unit is available and functional, so to speak, it can do something, but it does not perform any activity. It waits for an action from outside to start or restart an activity. And of course, the 4th state is the state of executing, which means the unit is available and functional and is actively performing an activity, or you could say pursues a purpose. And an activity could be part of the production or of the preparation or a maintenance process. And the second state machine for our machinery state is the machinery operation mode. It also consists of 4 different states of none, maintenance, setup, or processing. And none means that there is currently no machinery operation mode available for the machinery item. Maintenance means that the machinery item is set into maintenance mode with the intention to carry out maintenance or servicing activities of the machinery item. Setup means that the machinery item is set into setup mode with the intention to carry out setup, preparation, or post-processing activities of a production process. And we have processing, which means the machinery item is set into processing mode with the intention to carry out the value-adding activities. As I have mentioned already, the states are brought into OPC UA for machinery with the mechanism of state machines. This has several advantages. We could have taken an enumeration, for example, but an enumeration wouldn't be extendable. And this is a very important point for OPC UA for machinery, that our models are extendable and can be made more precise by the domain-specific companion specifications. And so you can see here, for example, the machinery item state is a state machine with all transitions allowed to each other. So for example, you can get from executing into not executing, or in not available or in out of service, or you can go again into executing. So all transitions are allowed. And if you want to use this state machine now, like for example, the OPC 40084 part 1 is doing, then you can extend it by defining substates. So for example, this is a specification for extrusion, and they said they need more specific states for the case of executing. And so they have the ready-to-run state, a controlled run, and a manual run, which are all executing states, but these are more precise substates. With the building block of machinery state, we can do first KPI calculations. KPI stands for Key Performance Indicators, and I brought an example here. So we have a machine in the time window of 8 hours, and a machine is 2 hours in the state of out of service, but with the mode of processing, so it should be processing, but it's out of service. Then we have 1 hour where the machine is not executing, but it still should do processing. And we have 5 hours where the machine is in executing and in processing. And if we take a look now at the ISO 22400 and we want to know the availability of the machine, then we will get an actual production time of 5 hours from the machine. And furthermore, we will have a planned busy time of 8 hours. And this is an information that usually doesn't come from the machine, but you will get it from another system. And if I divide now the actual production time by the planned busy time, then I will get an availability of 62.5%, which is pretty bad, to be honest. But as you can see here, it works with our machinery state interface to get first KPI figures, at least if you have the machinery item state and the machinery operation mode implemented. You can use the combination of the machinery item state and the machinery operation mode to get semi-E10 times. So for example, if the machinery operation mode is in none, then it doesn't really matter which machinery item state I will have a non-scheduled time. On the other hand, if I have the machinery item state of out of service, then I have a downtime. And it now depends on what mode the machine is in. So for example, if my machine should be processing, but it is out of service, then I will have most likely an unscheduled downtime. But if my machine is in the mode of maintenance and out of service, then I usually would have a scheduled downtime. Furthermore, if we take a look at the machinery operation mode in setup, then it really doesn't matter which machinery item state I am in. I have an engineering time, and I get a standby time with the combination of the machinery item state not executing and the machinery operation mode of processing. And of course, the most important time, I would say, is the productive time, and we have productive time with the combination of executing and processing. So this was my presentation on OPC UA for machinery. I hope that you get why we are putting so much work into this activity and why you should use OPC UA for machinery, and of course how you can use OPC UA for machinery. And if you have any questions left, don't hesitate to contact me or to ask them whenever the next opportunity comes up. Thank you very much for listening and have a nice day. Bye bye.
Thank you very much, Heiko. For me, and I predicted and repeated that multiple times, I predicted that OPC UA for machinery is the super important basic layer on top of OPC DI, which is built into the OPC UA framework by design. But if I would be a company doing MES or ERP stuff or SCADA, I often get the question, what is a companion spec I should start with implementing? And I'm always pointing to OPC UA for machinery because it has the fundamental building blocks which are the base for a lot of other specifications. Thank you very much, Heiko, again. Looking to the next speaker, I'm announcing Dr. Wolfgang Mahnke. He's working for the company Unified Automation. And he's also the leader of the OPC Foundation Harmonization Working Group. And there will be two presentations. The first presentation right now is about extending this OPC DI with actions. And Wolfgang is explaining us what this means in detail. Wolfgang.
Hello, and welcome to my presentation, Scheduling Actions in your OPC UA Server. My name is Wolfgang Mahnke. I'm working as consultant for the company Unified Automation, we produce software development kits for OPC UA and other products and services around OPC UA. I'm chair of the Harmonization Working Group of the OPC Foundation, and what I'm presenting today is actually a result of a subgroup of this working group. The purpose is we want to provide the capability to schedule actions in an OPC UA server that can be start the heating at from Monday to Friday at 7 a.m. and stop the heating again Monday to Friday at 8 p.m. You might want to generate an event at the end of each month. You might want to calibrate a device at a specific date, like the example here, the 20th of March 22. You might want to update your OPC UA certificate at the beginning of each month. And the background is, as I mentioned, it's developed in a sub-working group of the Harmonization Working Group. It is inspired by the BACnet scheduling mechanisms. So BACnet is specification standard used in building automation. However, our use cases, as you just have seen, are not necessarily only valid for building automation. The result becomes part of the base OPC UA specification, so it will become part 24 scheduler, and it's defined in its own namespace, so it's not in the namespace 0 of most parts of the base specification, but it will have its own namespace and therefore its own OPC UA node set file. The idea of the scheduling is, so first of all, you have the possibility to do weekly schedules. That means you can specify actions for each day of the week at specific times. And as you can see here in the example, on Monday, for example, at 4:30 p.m., you switch your heating into the night mode. On Friday, at the same time, you're turning it off, and you see there are some other, of course, at some point in time, you also want to turn it on. This example, each weekday, working day at 7 a.m. And in general, the model is built in a way that you can, per weekday, define a variable number of times where you want to do some actions, and then for each time, define a various number of actions you want to execute at that time. In addition to this weekly schedule, we also have the capability for special events. That means we're scheduling actions at special dates. And as you can see here in the example, we have, for example, recurring events stating in this case each Saturday of March 22. We want the heating on at 5 a.m. and turn it off at noon because there's always a school board and they want to have some warm rooms. The next one is you can define an interval, in this case from the 3rd of April until the 7th of April. There are some IT users meeting there, and so they want the heating on from 5 a.m. to 4:30 p.m. And you can also define it for specific dates, like on the 1st of April, the facility manager is doing something, so he wants the heating on starting at 5 a.m. and don't want to turn it off again. As you can see, the last row in this table is on priorities. So as you can imagine, so there might be some overlaps. And if there are overlaps, needs to be decided what action or what schedule to be taken, and therefore there's a priority, and the highest priority, of course, wins. The other stuff is not deployed then. And again, of course, you can define for each date several times, and you can execute several actions at each time. And of course, if a special event occurs, also the weekly schedule is overwritten. So you're not using the weekly schedule then, but you're using the special event. So they have a higher priority than this weekly schedule. The weekly schedule is used when there's no special event applied. The special events can also reference globally defined calendars. So in this example here, it references a calendar where some specific dates are defined. So the 18th of April, Easter Monday, sorry, the 26th of May for Ascension Day. You can also reference calendars where there are some recurring dates defined, like Christmas Eve and New Year's Eve. This is always the same on each year. And you can also define intervals, for example, in this case here, for some school vacations taking place. And that means that each scheduler can reference the same global calendar and use it as, and you don't need to define it in each schedule object again. The actions you can execute, it's an extensible model where you can define various types of actions. We have two predefined. The base action already provides the status code of the last action that was executed, the last time the action was executed, and then we define write local variable action, meaning you are writing to a specific variable which you need to define, and the value you need to define at a specific time when the action should be executed. This value is written into the variable, and as I mentioned, the status code then implies what the result of this write operation was. The second one we define is the call local action, call local method action, where you define which method on which object to execute, and if it has the method has input arguments, you have to define what values should go in there, and it provides, in addition to the status code, from the last call, the output values, if there are output values for the method call. The information model for this, so from my perspective, it's a rather simple model. So we define just two object types, one representing those global calendars, and the second one referencing, defining scheduling objects. And the scheduling object then has a weekly schedule, as I've just showed you, and an exception schedule for those special events. And the main things of this are then in the data structures used there. By the way, the scheduler also defines a property called local time. So it does consider that potentially, so OPC UA in general works with UTC time. But if your server in general in OPC UA is in a different time zone, you can also provide a local time on the server object. And now if the objects where you schedule the stuff on are in a different time zone than your server, you can also expose this information with this local time property. So let's take a look into the structure. So I only show this for those exception schedule. The weekly schedule is using the same structures, except for that it's not defining on what special dates it's happening. So here it's the special event type, where first of all the period is defined. So on what days something should be executed. And if we look into the data structure into a little bit more detail, it defines either a reference to a calendar, or it defines locally, so to say, in that structure, what dates are of effect. And this is in the calendar entry type, and the calendar entry type is either a date or a date range from to. The date is always defined by year, month, and day of month, day of week. So it's a little bit different than our UTC time, where there's also the day, or can be specified the day in it. You will see in a second why this is happening. The date range is using the same data structure and has a start date and an end date, of course. And let's take a deeper look into this date type. So the date type defines the year as an uint 16, and then it defines the month. That's an enum, having all the months in it, but it also has some special things in it, like the odd or the even, or not defining the month at all. We define the day of the month, also from 1 to 31. Then you have special things like defining the last day of the month, or only the odd days or the even days, or not defining it at all. You can also define the day of the week from Monday to Sunday, but also leave it open. So in a nutshell, you can use wildcards, and with those wildcards, those special things, you can define then repeating things that you leave out the year, and that means, oh yeah, each year it is repeated, but you can also leave out other things, and that means it's repeated accordingly. The definition of the time and the actions is done in this list of time actions, and the data type here is, so you have an array of times, and then each time has an array of actions. The time is defined with hour, minute, and second, so we don't have a very fine granularity resolution with picoseconds, milliseconds, or whatever, because this is not intended for things like real-time communication, control, whatever, but it's really, okay, at this point in time, this action should be executed. Then the actions is an array of base action type. This is base action type is an abstract type, only defining the status code, and then we have subtypes for the write local variable, defining a node ID, so it's a local variable of that server, and the value to be written, and the call local action method action type provides the local object, the local method, and the input arguments of that method call, and it provides you with this last output values from the last time the action has been executed. At that point in time, it provides the result of the output arguments. To summarize this, part 24 scheduler will actually be out as release candidate for the 105.02 version of the base specification that will come very soon. It has been developed in the harmonization working group. We had a specific subgroup doing this. It's inspired by the BACnet scheduling mechanism as it's used in building automation. However, the use cases are not limited to building automation, but you can do whatever you like with this. It's although it's part of the base specification because it's a very base concept, it's not a namespace 0 of the base specification, but it's its own namespace. The functionality is you define the affected day. You have the scheduler object with a weekly schedule and an exception schedule, or only one of those. You don't have to have both. You have to have at least one of those. The exception schedule can either define locally what dates are affected, or it can reference calendar objects which are globally defined, for example, for public holidays, as you have seen in my example. We have priorities when we have overlapping exception schedules, so the server knows which one to pick. And then for the day which is defined, you define times during that day, and per time a list of actions to be executed, and you can still look at the last result of such an action. And the concept of actions is extensible. We have predefined actions for writing local variables or calling local methods. And it can be used for various functionality, like calibrating your device, generating reports at specific times, renewing your OPC UA certificates, whatever you like. So that's it from my side. Thanks a lot for listening, and keep in mind the release candidate will be out very soon.
Thank you so much, Wolfgang. First, I have to make a correction. I have to correct myself. So it was not an extension on OPC DI. I learned it is an own specification. It's a core specification. And we have to make that as a text overlay in the recording, what we share. So, okay. Content-wise, super interesting. I just thought about, hey, if this would have been available just 15 years ago when I did the automation and controlling my own house with a PLC, including an OPC UA server, I could have done all the blinds going up and down on different days and different times in a week or at the weekend much more easier instead of doing this in PLC logic. Okay, but I also believe this is not only for the building automation area. Immediately there are so many ideas bubbling up, starting reports on something where devices collect information and then you can configure easily in action where to push data into cloud systems and so on. So fantastic work. Thank you very much, Wolfgang. And with this, I'm introducing the next speaker or the next presentation, because the speaker is again Wolfgang, but this time it's about asset management and a common information model to do this. So again, Wolfgang, we are listening to your presentation.
Hello and welcome to my presentation on common model to manage assets with OPC UA. My name's still Wolfgang Mahnke and I'm still working for Unified Automation. We're selling SDKs for OPC UA development and so on. And I'm also chair of the OPC Foundation Harmonization Working Group. And what I'm presenting now is also a result of that working group. And the background of that is asset management is a common use case in many companion specifications. Asset management applications typically access assets defined in various companion specifications. For example, in your factory you have robots, machine tools and so on, and you want to access asset-related information for all of them, and you would prefer to do this in a common way. And so the idea is to create a base specification with base concept of asset management, which can then be used and refined in companion specifications, but of course also directly in vendor-specific models. And the idea is also the base concepts can be used as needed, so it's not an all or nothing. You don't have to implement everything of that specification, but you can pick what you like, with the exception of the identification of the asset is actually needed for all the other use cases as well. So that's a very basic thing, but everything else you can decide on what you actually want to deploy to your companion specification or to your vendor implementation. And we're also trying to reuse existing base specifications as good as possible. For example, the devices specification addresses a lot of use cases in that area. We're using alias names, dictionary references, and so on, as you will see. General approach was, so we had an initial workshop when it was still possible to have a face-to-face meeting in January 2020 in Frankfurt. 40 participants from various domains. We had 27 presentations from end users, system integrators, IT, OT vendors, representing standardization bodies, and so on. And we had a lot of information exchange, and we created an initial set of use cases which would make sense to address in a more common way. And then a sub-working group was created inside the harmonization working group, and we started in April 2020 with bi-weekly meetings, and we had those bi-weekly meetings until recently. And we defined and prioritized use cases based, of course, on the initial use cases we created in that workshop. And then for the prioritized use cases, per use case, we defined a base information model addressing the use case. And actually, we're not always defining a new one, but often we're just using something from some other specifications, as you will see. The status is the first version has been released already beginning of this year, version 1.0, addressed a couple of use cases. I will not go over this list now. We will walk over each use case in an individual slide. Now we have out a release candidate of the version 1.01, which is addressing a few more use cases. And let's talk about the use cases. So a very important one is the identification of an asset. So the user wants to identify the asset in a globally unique manner, meaning that even if you access information from the asset from two different servers, you want to make sure that you realize, oh, this is actually the same asset. And the user also would like to set up user-specific information to that asset. The solution we've decided to use is actually using the identification of the part 100 devices specification as base. This is already used in many companion specifications today. We made the product instance URI, that's one of the properties defined there, as the mandatory global unique ID. We're using the asset ID to be set by the user, which is also defined in the devices spec. In a nutshell, that means we're not defining any new nodes or anything here, but just profiles, how to use what's defined in the devices specification. The devices specification allows us to use it in different ways. So you can either use the interface or the object types defined there. You can use an identification object having the properties beneath, or you can have them flat on the type defined. The server can select what he wants to support, so we want to be as open as possible that as many companion specs as already have deployed the device specification fulfill our specification, and that means the client needs to be able to understand the different approaches, but the server can select. And based on that, many companion specifications which are released already do support this use case, like, for example, the machinery specification and all the derived companion specifications already support this today. Second use case is the discovery of assets. So user wants to access all the assets of the OPC UA server. Here we're using the alias names, which is defined in the base specification. So we have a new standardized alias category for assets, and we have two ways how to access them from there. One is searching by the asset ID, and the other one searching by the product instance URI. And those alias names, I don't want to go into the details how they are working, that's from the base specification. They point then to the places in the address space where the asset is actually living, so to say. So that's a fast path to access all the assets of the server. We have a use case to provide information about the skills, capabilities of an asset. And in this case, we're defining a standardized folder called capacities. And we leave open what's actually in those capacities. And the idea is that you're referencing external specifications like E-class or the Common Data Dictionary of the IEC, defining those kinds of capabilities. So they are already defined, so we don't need to repeat this, and so you can still decide on what external standard you want to use for that. We also had here, so this works fine for standardized things. Like here you can see something, or measuring the temperature. For other things like the machine can actually produce, for example, a Lego brick. This is more application specific, so we decided this base working group is not the right spot to do this, and we already talked with the machinery working group, and it's in the backlog of that working group to address those things in that specification. Another requirement was to expose the requirements of an asset. So the user wants to deploy the asset somewhere, and he needs to know, okay, what connection values does it have, what plug types, what are the environmental conditions, how warm can it be, what's the humidity that's allowed, the dimensions and weight of the asset, and so on. Solution very similar to what you've just have seen. So we have another folder called requirements, and again we're referencing to other specification who already defined those things, and you can put that information under the requirements folder. And as you can see here in the example, you can also use the grouping mechanisms, so it doesn't have to be a flat list. The next use case is called version information. There's actually, if you read the details of this, there's a little bit more in this, including reference to documentation and stuff like this. In many cases, we're using the base specification and part 100 devices. For going for different version information. OPC UA capabilities already described in the base specification. So here again, for most things, we don't define new nodes. We just have profiles referencing to the other specifications. And with one exception, that we have this add-in defined documentation links type, where you can actually reference to external sources. And this also provides the capability that the user can point to external sources, so can add this information to the server. We have main use cases for the health status, and then some sub-use cases for that. That's providing information about the health status, and there's the idea to have a simple high-level view, but also detailed information for failure conditions. You want to have this the importance of the failure categorized. You want to get them reported in a harmonized way, and you also want to see how it's changing over time. And the solution is we use again the devices specification. There's the device health status, so no new nodes, just profiles defined for that. For more detailed information, we're using alarms with severity for the importance, and this is in the base spec, and also devices is using those alarms. And we have an interface for alarm types to identify possible root causes defined, and standardized condition classes to report things in a harmonized way. For providing the health information over time, we're just using the history capabilities of OPC UA, so you can access the history of event to do that. So here again, no new nodes needed to be defined for that. We want to provide information about maintenance activities, and our solution is we're using conditions to expose planned maintenance events and current maintenance events, and we have a special interface that can be used on conditions to provide the main information there, and to access the history of the maintenance activities, we're again using the history of events. We want to provide a hierarchical location, and there we provide two ways. One is just popping a property to the asset, and the second one is having a hierarchy of objects, and you can reference from there to the assets, and you can either support one or the other or both of them, so they also work together. We have other locations. First of all, we want to provide the local time of an asset. We're using their as we did in the presentation before, we're using the local time properties, so you can put them directly on an asset to know on which time zone the asset is located. For the digital location, we just have a property providing a link to the digital location. And for the operational location, we're using the same approach as for the hierarchical location, so you can have the property and or the grouping objects to do that. To identify the structure, the internal structure of the asset with sub-assets, we're just using the base OPC UA functionality with hierarchical references. So we're not defining anything specific there, but just saying, okay, you just put the sub-asset under the main asset, so to say, and you can also do some grouping there. So in a nutshell, the client just needs to go there and browse for hierarchical references to see the substructure of the asset. The the classification of an asset. Here, the idea is not that we define one classification. Assets can be classified by different manners, but we define the infrastructure, the capability for classification, and here we're using again those external references so that you can use, for example, E-class, Common Data Directory, as classification mechanism. So again, no new nodes, just profiles defined. And talking about profiles, we have one server facet, one client facet defined, and as you can see, both have mandatory, I hope you can read it, both have mandatory the asset identification, and everything else is optional, so you can select what part you want to support and what part you don't want to support. And to summarize this, so we have now the part 110, Asset Management Basics, out. Release is already out, and new release candidate also out, so we will soon have a new release 101. It's a base specification for asset management, can be applied on various companion specifications and implementations directly, but the general idea is that you probably would like to define still a companion specification where for this specific domain you refine the asset management stuff. The concepts can be used as needed, so you have seen a lot of use cases. You don't need to support all of them, you just pick what you want to have. If you pick any of them, you need to support the identification, otherwise nothing will work. We're using existing base specifications, specifically, I mean, the general base specifications, specifically the aliases, the dictionary references, and also the devices specification. And since we're doing this, and they are very popular also in other companion specification, various different use cases defined here are already supported as defined here by released companion specifications, like, for example, the machinery specification. The next step the working group will do is we have to do the release of the 101, so there might be some review comments coming back. We need to work them in. Otherwise, the idea is we've done our work for now, so we will wait now. We still have a bunch of use cases which were not in the first priority list, but we said, okay, we want to get those things applied first, and maybe after a year we come back together and do a new kickoff and investigate the list of use cases we haven't addressed, and maybe think also about other use cases, with the exception that if there are, of course, issues with the specification, or there's something very urgent somebody wants to add there, that this can be done. If you want to be part in those next steps, feel free to contact me and join this working group, but be aware, we will not do any work, hopefully, the next year. Thanks a lot for listening.
Thank you very much, Wolfgang. We feel your spirit and your engagement and your passion, so thank you very much for that. I'm not here at the keyboard right now. I would add a question for asset management. I hear always identificator, and then looking to the market, I see that every organization has an identificator. And we also learned this from the UA for machinery in the harmonization group. So I would ask later on a question, okay, what is the correct identificator, and are we aligned, and do we need to harmonize? Maybe we can add that to the Q&A part. Anyway, thank you very much. That was the last presentation of the day 3 of the OPC Day International 2022. It's impossible to give all of them time here to present the status. So I'm glad that we today had new announcements, exciting announcement. We had fantastic, passionate presenters, but we also learned about the need and the champions class of modeling and standardization of the harmonization inside the VDMA, which is UA for machinery, but also on the side of the OPC Foundation, resulting in new activities like actions and also the asset management. So again, I like to thank the audience for listening again today. Hope you join us again tomorrow on day 4. I like to thank to all the speakers, I'd like to thank Alex for fantastic moderation. Have a good day, have a good night, good evening, wherever you are in the world. See you. Bye-bye.